Hello bachcho, let's read this question. So the question says at 298 Kelvin, the bond energies of CH, CC, C double bond C and H single bond H bonds are respectively 414, 347, 615 and 435 kilojoule mole inverse. The value of enthalpy change for the reaction CH2 double bond CH2 gas plus H2 gas giving CH3 single bond CH3 gas at 298 Kelvin will be. So here the key concept is enthalpy of reaction in terms of bond enthalpy. Alright, so यहाँ पर जो reaction given है that is CH2 double bond CH2, so we can write it like this HC double bond C और यहाँ पर दो single bond CH plus hydrogen that looks like this H single bond H gives CH3 single bond CH3 which is like this H C C H और यहाँ पर चार hydrogen 1 2 3 and 4. Alright, so इस reaction की हमें enthalpy calculate करनी है with the help of these bond enthalpies. So we know that enthalpy of reaction is equal to sum of bond enthalpy of reactants minus sum of bond enthalpy of products. Alright, so reactants में क्या क्या है, एक C double bond C, चार C single bond H और एक H single bond H. So bond enthalpy of C double bond C plus 4 multiplied by bond enthalpy of C single bond H plus bond enthalpy of H single bond H minus product में क्या है C single bond C और 6 C single bond H minus bond enthalpy of C single bond C minus 6 multiplied by bond enthalpy of C single bond H. So यहाँ पर हम values put कर सकते हैं and before that यहाँ पर 4 multiplied by bond enthalpy of C single bond H minus 6 multiplied by bond enthalpy of C single bond H. So these two get cancelled और यहाँ पर हो जाएगा 2 multiplied by bond enthalpy of C single bond H. So यहाँ पर अगर हम values put करें bond enthalpy of C double bond C is 615 plus bond enthalpy of H single bond H is 435 minus bond enthalpy of C single bond C is 347 minus bond enthalpy of C single bond H is 414. So 2 multiplied by 414. So इसकी जो value है this is equal to minus 125 kilojoule mole inverse. So the enthalpy of reaction delta H reaction is equal to minus 125 kilojoule mole inverse. This is the required answer and I hope you understood the concept well. Best of luck.